Welcome to AI Podcast, where we make new research feel like a conversation over coffee.
I've got my mug ready. What's on the menu today?
A paper from EMNLP called BacktrackAgent. In a sentence, it teaches GUI agents to notice when a click goes wrong and then back up to fix it instead of charging ahead.
So like when your GPS says recalculating after you miss a turn.
Exactly. The team, led by Qinzhuo at Xiaomi, wraps a normal action generator with three helpers: a verifier, a judger, and a reflector.
Give me the elevator pitch on each in plain English.
The verifier is the sanity check. Did we try to tap something that exists, and was that a legal move? The judger is the progress inspector. After the click, does the new screen look closer to the goal or not? And the reflector is the fixer. If things went sideways, it backtracks one step and rewrites the action.
Right, so it's not just plan, act, pray. It's plan, act, check, and if needed, rewind and try again.
That's the vibe. And there's a training twist. They turn the verifier, and judger signals into feedback during training. So the core policy learns to prefer actions that actually improve the state.
Okay, take me a step back. What problem are they solving that earlier agents struggled with?
GUI tasks are long and brittle. One sloppy tap can derail an entire sequence. Most agents focus on predicting the next action from the current screen, but they don't look at the screen after the action to see if it helped. It's like grading someone's technique without checking whether the ball went in the hoop.
Style points without the score. So how do they test this?
On two big mobile UI benchmarks, Mobile 3M and Auto UI, they compare against solid baselines, including a recent system called Reach Agent. The headline is a clear bump in task success on both datasets, roughly an 8-point lift on Mobile 3M.
Nice. Any fine print?
Speed. With the extra checks and occasional do-overs, the agent runs at about half the speed of a plain generator-only setup.
Trade a bit of speed for fewer faceplants. That feels fair for many apps. Do we know which of the three helpers mattered most?
Their ablation suggests the judger is the linchpin. Removing it hurts more than removing the verifier, and the backtracking itself is essential. Also, when they trained using real post-click screens rather than simulated ones, learning got noticeably better.
That last bit resonates. The weird glitches you hit in the wild are hard to fake. How does the backtracking work in practice? Do they always undo just one step?
They back up one screen and let the reflector propose a new action. There's a small cap on how many retries so it doesn't spin.
And how good is the error detector? Can it catch everything?
Not everything. It's precise, meaning when it says something's wrong, it's often right, but it misses a fair number of mistakes. The silver lining is that when it does flag an error, the recovery fixes a meaningful chunk. Think roughly a third of those flagged cases.
So, a solid safety net, even if it doesn't catch every stumble. What about the model under the hood?
They build on Qinzhuo VL at the 7 billion scale. It would be great to see the same idea tested on other vision language backbones to prove it's not a one-model trick.
And who are the folks behind it again?
Qinzhuo and colleagues at Xiaomi's MILM Plus group, industry team with a very practical bent.
I like the structure, but I'm curious about the training signal. How do the verifier and judger actually steer the policy?
Picture a coach who watches not just your swing, but where the ball lands. If the ball moves you closer to the target, you get a small reward. If not, that's a negative signal. Those little nudges accumulate over thousands of steps, shaping the action generator toward moves that lead to better screens.
Got it. Outcome-aware coaching. Any pitfalls you noticed?
A few. First, the moderate recall means plenty of errors slip through. Second, because the judger runs at inference, you pay latency. Third, some datasets only had simulated next screens for wrong actions, and the paper shows that's weaker than training on real outcomes.
Right, nothing beats the messy truth of real taps and mistaps. Do they say anything about openness and reproducibility?
They include training details and a responsible checklist, and they say they'll release code and data. The proof will be in independent reruns and trying it across different environments.
Let's make it tactile. Say I'm asking a phone agent to book a ride. The agent opens the app, aims for the pickup field, but taps a banner ad instead. Walk me through what BacktrackAgent would do.
The verifier might notice the action didn't change the app in a meaningful way, or that it landed on a promo screen. The judger looks at the new screen and says, "This isn't closer to booking a ride." The reflector hits back, returns to the prior screen, and tries a different action. Maybe scroll first, then tap the pickup field. If that looks better, the agent carries on.
That's relatable. I've done that exact dance a dozen times. What would you improve next?
Two things. Make the judger lighter and faster. Distill it, cast judgments for similar screens. Let it early exit when confident. And boost recall with smarter change detection, like visual diffs plus text. Not just one or the other.
I'd also lean into collecting more real interaction logs across a variety of apps and devices. If the model learns from true outcomes, it should generalize better.
Totally. And another frontier is policy over backtracking itself, learning when to back up and how far. Sometimes one step isn't enough. Sometimes any backtrack is overkill.
Before we wrap, can you give listeners a clean takeaway?
BacktrackAgent brings a simple habit that humans use all the time to GUI agents. Check what happened after you act, and if it's wrong, unwind and try a smarter move. That habit noticeably improves end-to-end success on mobile UI tasks with a reasonable cost and speed.
And the road ahead is about catching more mistakes faster, learning from real clicks, and trimming the overhead so the agent feels snappy.
Exactly. Less brittle, more self-aware agents.
That's our show. The paper is BacktrackAgent from EMNLP by Qinzhuo Wu and team at Xiaomi. If you build UI agents, it's a thoughtful blueprint.
Thanks for listening to AI Podcasts. Send us the next paper you want us to unpack.
See you next time.